So after kind of wrecking us in a lot of problems, they're just kind of throwing us some softballs here because they're asking us to calculate the pH of a buffer. And the key things here are this: do we have to figure what our buffer is made up of, or do they give it to us? And if you take a look, they give us 0.66 molar of the base, and they give us the 2.5 molar of the acid. So if they give us an acid and a base, that feels an awful lot like they're just asking us to Henderson-Hasselbalch, which is our favorite thing to do. So we're going to do that right now. So first things first, let's make note of a couple of things here. We're pretty okay with the idea that this is a base because it tells you it's a base with a Kb of 4.4 times 10 to the negative 4. Then they say you have 2.5 molar of methylammonium chloride, and they give you this formula right here. And I just want to point out to you here that if you take a look at this, this is really an acid. Remember, the positive side of a salt is the acid portion, and the negative side is the base portion. But this is Cl minus, which is the conjugate of a strong acid. This is a pathetic. It doesn't do anything. So in reality, the two things that we have that are interacting with each other, and you could write the equation either way. I'm going to tell you right now, if I was doing this on the test, I wouldn't write out anything. I would just plug it into Henderson-Hasselbalch. But just so you know what we're dealing with here, we have CH3 NH2, and if I wanted to, I could throw that into water. And since this is a base, it's going to grab a hydrogen off of this. And what are we going to end up with? We're going to end up with CH3 NH3 plus OH minus. Again, one of the reasons they really love using things like this is that it looks like it might possibly be an acid, but the fact that they tell you it's a weak base kind of makes that a moot point. Now, the other thing is, and they did us a nice favor here, they just gave us the molarity of this, and then they're like, hey, just in case that's not enough, let's give you the molarity of this. So I'm just going to write this in here, and this is my equilibrium, or my initial values of both these here. I have 0.66 molar of this, and I have 2.5 molar of this. These are my initial values, and we could, if we wanted to, we have 0 of this, we could do an ice problem. But why would we do an ice problem, right? So let's take a look at our Henderson-Hasselbalch equation, because that is the giver of all good things. pH is equal to pKa plus the log of the base, I call it, over the acid. Now, here's the thing. There's another version of this that you can use that actually has a pKb, and you solve for pOH. But there's no reason to do this because this works for us, and they gave us the Kb. Now, is that giving us the pKa? No, but if they're giving us the Kb, we can figure out the pKb by taking the negative log of this, and then couldn't we subtract them from 14 to figure out our pKa? And then these two numbers right here, all we're going to do is we're going to plug this 0.66 into here and this 2.5 into here. So let's just jump right to this here. And in this particular case, and I'm going to do the pK, the Kb over here on the side. If I want to figure out the pKb, it's going to be equal to the negative log of 4.4 times 10 to the negative 4. And when I do that, I'm going to end up with 3.3565. That's my pKb. And if I want to, I can just go then 14, subtract 3.3565, and that's going to be equal my pKa. So when I do that, my value ends up being 10.6435. Now, if we take a look, when we plug our log values in, so we're going to have 10.6435 in here. We're going to add that to the log of 0.66 all over 2.5, which when we do the math on that gives us a negative 0.5784 that we're going to subtract from 10.6435, and my new pH is going to be equal to 10.0651. And if they do like normal, they're going to ask us to do this to 2 decimal places. And since we are using 2 significant figures here and 2 significant figures here, it makes sense that we would cut off right here. But be wary, because this 5 is going to round this up, and so our final answer needs to be pH of 10.07. Hopefully this has been helpful to you.